Hello everyone. In today's video, we are going to see carboxylic acid. Carboxylic acids are those compounds in which COOH group is present as a functional group, or we can say it as CO2H. We can draw it like this: C double bond O and OH. So this group is present in the carboxylic acids. So let's draw the structure of first four carboxylic acids. So the first member is C double bond O OH, and there is H present over here. We can write it as CHCOOH, or we can say it as HCO2H, or we can say it as CH2O2. There are different ways to write the same structure, and the name of this compound with one carbon is methanoic acid. You know already, meth means it's always for one carbon, and methanoic acid is a characteristic naming method for carboxylic acid. Let's see the next one. Next we have the two carbon carboxylic acid. You know, C double bond OH is always present, and there is one more carbon present over here along with the three hydrogens like this. So we can write it as CH3COOH, or it can be CH3CO2H, or it is C2H4O2 and is known as ethanoic acid. Next one, 3 carbon. On the left side there will be two more carbons. So we can represent it as CH3, CH2, COOH. You can see this part is CH3, this is CH2, this is COOH. And then we can say it as C2H5COOH, or we can say it C3H6O2 and is named as propanoic acid. Similarly, we can draw the fourth structure that contain the carboxyl group. Along with there'll be three more carbons present like this. So complete the valencies using hydrogen like this. So it will be C3H7COOH, or it is C3H7CO2H, or it is C4H8 and O2. It's called as butanoic acid. So from these formulas, we can work out the general formula of carboxylic acid. So we can make, there are two types of general formulas that we can have. The one that we can make with the help of these structures. Okay, this one will be, there are two carbons and there are five hydrogens. We can say it as CnH2n plus 1 COOH. This is the first general formula of carboxylic acid. Then using these structures, using these formulas, we can make another general formula for carboxylic acid, and that would be, you can say whatever number of carbons we have, the twice number of hydrogens we got. So it would be CnH2nO2. So we can have these two formulas. Using these two formulas, you can construct the carboxylic acid, the formula of any carboxylic acid. So let's say we have to draw the formula of carboxylic acid with, let's say, 7 carbons. So we will make carboxyl group first of all, and then since we have to make total 7 carbons, 1 carbon we have already made. Now we're left with 6 carbons. So we'll make 6, over here C6, and H would be C6 times 2 is 12 plus 1 13. So C6H13COOH. Or if you write it in this form, it would be C7 and H14O2. So there we can make any formula, like we can make formula with C15, H would be 31 COOH, or it would be C16 H32O2. Okay, they can ask you to draw the displayed formula. So let's write the displayed formula of, let's say, pentanoic acid. Now, pentanoic acid contain 5 carbon. So let's make 5 carbon first of all. These are the 5 carbons, and then the 1 carbon you will use in making of the carboxylic acid. Okay, so this is how you will make it fully displayed. Fully displayed means all atoms and all bonds, they has to be shown. So this is the fully displayed formula of pentanoic acid. Now let's see the reactions of carboxylic acids. One thing that you must know, that carboxylic acid are weak acids. You know, weak acids are those acids which are partially ionized in water. So whatever carboxylic acid you have, for example, we have C2H5COOH, it's propanoic acid, and you put in water, so it will slightly ionize, the reversible sign. So it will be C2H5COO negative plus H positive. So always this H, it will be dissociated, it will be broken, it will be separated to make this negative ion. So this compound is known as propanoic acid, and this is called as propanoate ion. We can draw the structure of propanoate ion as well. It's like this: C double bond O, O with a negative charge, and there'll be H present over here like this. Okay, now carboxylic acids, they are acids, and you know acids react with metals, metal oxides, metal carbonates. Let's see the reactions of carboxylic acids as acid. So you can say there are two types of reactions. The first type is that they behave as acid. In these reactions, the first one is the reaction with metals. So we have metal plus acid. So whenever you know metal plus acid react, they give you a salt plus hydrogen gas is released. So we can take any metal, like we can take a magnesium metal, react with acid. Acid is CH3COOH. Now what happens? That this H, it is being replaced by the Mg, and Mg, you know, is 2 plus, while this carboxyl, this ethanoate ion, it will be negative 1. So we'll construct the formula as CH3COO, and there'll be a twice over here along with Mg plus H2. So now you have to balance this reaction. So we'll write 2 here to balance this equation. So this is how the magnesium metal react with the carboxylic acid. And we get this compound, its name is magnesium ethanoate. It's a salt. We can take any carboxylic acid and they react similarly in this way. So the next reaction of carboxylic acid as acid is that they react with metal oxides and plus acid. In this reaction we get a salt plus water. So let's write the metal oxide. For example, any metal oxide we can take, like we can take calcium oxide, react with C5H11COOH. So it react with calcium oxide. The same thing happens, calcium will replace hydrogen, and we get C5H11COO. It will be a negative 1 ion, and calcium is 2 plus. You write 2 here, and to make it calcium along with the water. Let's balance this equation, writing 2 here. This reaction, it's between the acid and the base, because calcium oxide is a base, the metal oxide is the base, while it's an acid. So we can call this reaction as the neutralization reaction. So let's see the next reaction of carboxylic acid, number 3, as acid, and that is the metal hydroxides. Metal hydroxides plus acid, they give you salt plus water as well. So any metal hydroxide we can take, like we have sodium hydroxide reacting with C2H5COOH. So what we'll get? Sodium will replace hydrogen and we get C2H5COONA along with water is formed. And this is the salt, that is sodium propanoate. And this is also the neutralization reaction because it involves the reaction of an acid and a base. We can represent this reaction in the form of ionic equation, H plus OH negative, and it gives you H2O. And finally, number fourth reaction of carboxylic acid as acid is the metal carbonate plus acid. So when metal carbonate and acid are reacted, they give you a salt plus water plus carbon dioxide. So let's write this reaction. So let's say we have a metal carbonate like sodium carbonate and Na2CO3 reacted with an acid like CH3COOH, and it will form a salt. And what is the salt? Sodium will replace this hydrogen and we will get CH3COONA plus H2O plus CO2. Now let's balance this equation. Sodiums, there are 2 here, so we need to write 2 here and then 2 here will balance it. Okay, in this reaction we will see that since carbon dioxide gas is formed, we will observe fizzing, or we can say the effervescence, or a gas, bubbles of the gas will be seen. So on the basis of this, we can use this reaction as an identification test for the presence of carboxylic acid. Other compounds like alcohols, they do not react with sodium carbonate. Similarly, we can have another example. For example, calcium carbonate reacted with a bigger carboxylic acid, for example, C5H11COOH. The reaction is similar. Calcium metal will replace this hydrogen and we get C5H11COO. That is -1 charge and calcium is 2 plus. So we write 2 here and calcium along with H2O plus CO2 is released. So let's balance writing 2 here. So this is how you can see that carboxylic acid, they reacted with metals, metal oxide, metal hydroxide and metal carbonates, and they behave as acids. Now let's see the next reaction of carboxylic acid, and that is known as esterification. Esterification involves the formation of esters. Esters are produced by the reaction of carboxylic acid with alcohols. So any carboxylic acid and alcohol, they can be reacted to give esters. So we get an ester plus water. This reaction requires the conditions, that is, we need concentrated sulfuric acid is used as catalyst and we have to heat it. Now let's write some reaction. For example, we have CH3, C double bond O and OH. This is the carboxylic acid reacted with an alcohol. For example, we have C2H5OH. Ethanol is reacted with carboxylic acid. This is a reversible reaction, remember. Reversible reaction, concentrated sulfuric acid is used as catalyst, so we have to heat it. What happens that OH is removed from carboxylic acid and H is removed from the alcohol. That makes it water. So along with water, what we will get? the two portions that we have just got, that is CH3CO C double bond O, this one, it will attach with this part, and the free end, like this end, it will bind with this end of carboxylic acid. So let's complete this structure. It would be CH3 C double bond O O C2H5 plus H2O. This is an ester. How will you say that it's an ester? Esters, they have their functional group which contain oxygen, like C double bond O, and next to O there has to be one carbon present. These are called as esters. So you can say the functional group for esters is this C double bond O, and next to O there has to be one carbon. So we call that carbon as alkyl group. On the left side you can have hydrogen, or you can have an alkyl group. It can be alkyl or it can be hydrogen as well. How we name esters? Let's see that. Esters, they are like this ester that we have just made. Let's name this. Remember, this ester is made from an alcohol part and the carboxylic acid part. The right side is the alcohol part. You will first name this one. It's C2H5. It's 2 carbon. So 2 carbon alkyl group. The 2 carbon alkyl group, it is called as ethyl. While we got 2 carbons over here, and they will also be named with eth. Esters, they are named, their names end with noate. So we got ethyl ethanoate. This is the name of this ester. So we can construct any ester. For example, we have some bigger one. For example, this one C double bond O, O, and there are 2 carbons over here, and there is 1 carbon present. Sorry, let's make 2 more carbons over here. Let's see this one. So in this ester, on the right side we got this 2 carbon alkyl. It is the ethyl, and this one, this side, it contains 3 carbons. So this one will be called as ethyl, and this side, this one will be called as propanoate. So the name of this compound is ethyl propanoate. Now let's say we are given with the name of some ester. For example, they say propyl butanoate. We have to make this structure. Propyl is a 3 carbon alkyl. So first of all, make this structure, this one. Okay, then propyl is the alcohol part, that will make it over here. Propyl contains 3 carbons, so make 3 carbons over here, and then butanoate, the 4 carbons. 1 carbon is already there, so make 3 more carbons over here like this. So, and then complete the valencies of carbon using hydrogen like this. So this is the structure of propyl butanoate. Using these formulas, we can make the general formula for esters, which is CnH2n plus 1 C double O, and on the other side we can make like Cm H2m plus 1, because we got 2 different alkyl groups. On the left side we got alkyl, on the right side we got an alkyl group present in the esters. Fine. Now let's see the uses of esters. So there are 3 uses of esters. One, they are used as solvent. Second, they are used as flavors, because esters are actually sweet smelling liquids, so they are used as flavors, and they are used in perfumes. Because of their sweet smell, they are used as perfumes, flavors, and as a solvent. So this is all about the carboxylic acid and esters. So next thing that we have to see is isomerism in esters and carboxylic acids. Let's see that. Carboxylic acid and esters, they can be isomers of each other. For example, we have C double bond O, OH, and there is hydrogens over here. This is 2 carbon ethanoic acid. So what we can do, that we can transfer this carbon towards the right side, and what we'll get, it will be C double bond O, and O will have 1 carbon present over here, and hydrogen will be present over here. So you just have to shift the carbon onto the right side. Hydrogens, remember, they'll be automatically be, you can say, filled. You just need to keep this structure intact, okay, and don't change the structure, just keep the structure intact and take 1 carbon from this side to the other side, and then complete the valencies with the hydrogen. So this will be your ester, and its name will be methyl. It is 1 carbon methyl, and this is also 1 carbon, it's methyl methanoate. So let's have the next one. For example, we have a 3 carbon carboxylic acid. This is called as propanoic acid. So we can shift uh, the left side carbon one by one onto the right side. So keeping this structure intact. Now in this case we have 2 carbons present on the left side. So let's transfer 1 carbon on the right side, and 1 carbon is still there on the left side. Now complete the valencies. It will be the next isomer. Then the third isomer, it would be what? Again, keeping this structure intact, we will transfer both of these carbons onto the right side. Over here, shift the 2 carbons, and the left side will left with hydrogen, while we will complete the valencies over here with the hydrogens like this. Now let's name these 3 compounds. This one is propanoic acid. It's a carboxylic acid. You know, isomers, they have same molecular formula but different structural formula. This is what? This is methyl, and there are 2 carbons over here. So it's methyl ethanoate. Next one is this one. This side is ethyl, and there is 1 carbon. It's ethyl methanoate. These are isomers of propanoic acid. Now we can have bigger isomers as well. There's no problem in it. For example, we have an ester like this with 3 carbons over here, and there is hydrogen over here, and it is asked to draw the isomer of another ester, the isomer that is also an ester. So what we can do is we can make the branching. For example, on the right side we got 3 carbons, so we can write it like this. So this will be the isomer of the ester that we have just drawn. So this is all about the carboxylic acids, the reactions, the esters, and the isomerism in carboxylic acid and esters. Hope you have learnt all these things. Goodbye from now.